Good morning.
Good morning.
Am I visible? Audible?
Yes, ma'am. Good morning,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Oh, good morning.
Good morning, ma'am.
Good morning.
Good morning, ma'am. Good morning, ma'am.
Good morning. Okay, so last class we have discussed up to the binary vapor cycles. So there we have discussed the drawback, certain ideal working fluids we have discussed, and there were what should be the characteristics of this ideal working fluid. That one also we have discussed. So in case of our steam power cycle, we are using the water as the working fluid, in which we can go up to the temperature of your 375 degree Celsius. Okay, so where we can get the superheated steam, and the water saturation temperature is generally that is that completely that liquid will convert it to the vapor, that range of temperature at particular pressure that will vary. So suppose in case of the 12 bar, that saturation temperature will be around your 187 degree Celsius at the 12 bar. Okay, so at the particular pressure, we will have the saturation temperature. So as we have discussed that we should not go to the high pressure, so that it will be limited up for the metallurgical limit, so that we can also control the mean temperature of heat addition. So our main aim is to increase the plant efficiency and power output, right? So a reheat cycle we are using. So in that case, generally we are increasing the mean temperature of heat addition, where we have also certain increase in the pressure. So we should not go beyond the above the permissible limit of the working pressure. Working pressure means that steam generating pressure, and that condenser pressure should not be, it should not be very much less, so that we have to maintain the vacuum pressure. um, Means we should not face any problem to maintain the vacuum pressure, right? So that we have discussed last class. So there are the certain working fluid, ideal working fluid. Generally, we can use in the binary vapor cycle. Binary vapor cycle means there we are using the two cycle, right? One is your the cycle which will give the heat to the steam cycle, so that it can increase the plant efficiency. So in that case, we can use the different working fluids which can operate at the high temperature range. So those working fluids are your diphenyl ether, aluminum bromide, and mercury. Generally, we are using the mercury as the working fluid in case of the binary vapor cycle. So because it can operate at the high temperature range. So if we are considering at the pressure 12 bar, and the saturation temperature of water is 187 degrees Celsius, and your mercury is your 482.5 degrees Celsius, and your aluminum bromide is generally that is your 560 degree Celsius. Okay, so if you are observing this is the aluminum bromide. So still it is not used in the binary vapor cycle. Still it is in the research stage, but people have used this mercury binary cycle. And here you can see that at the 12 bar we have the high temperature of heat addition. That means the mean temperature of heat addition is at this point. Okay, so because of this one, we can uh, um, add the less heat to the to heat the to get the saturated vapor. So this is the reason why we are using the mercury. But this mercury we cannot use at the low temperature of operation, because in this case, as it is having the vaporization pressure is very much less. So if you are using this mercury cycle at the low operating temperature range, in that case what will happen, you have to create the more vacuum in case of your condenser, as well as the specific volume generated after the condenser, that will increase. So we have to use the bigger size of the condenser. Okay, so that is one drawback to use the mercury, but still people are utilizing to get some energy recovery, and means in case of metallurgical limit we can use this type of cycle. Also we can use this type of cycle to increase the plant thermal efficiency. Now I'm going to discuss the binary vapor cycle with the help of the schematic diagram. So if you are observing this one, this is the schematic diagram for the arrangement of your two cycle or binary cycle. So one is your mercury cycle, another one is your steam cycle. So this one is the TS plot. If you are observing, the process is given 1, B, C, D, and A. So this is for the mercury cycle. Here mkg of mercury is circulated inside the cycle, and it is linked with the steam cycle. So the heat rejected during the uh, condenser of mercury cycle, that is your VC process. So that will be utilized to heat the working fluid in case of the steam cycle. So this one is the steam cycle. So here in 5-6 process that will be, and that heat rejected will be utilized in this process. Okay, so if you will observe this diagram, okay, so this arrangement is for the A, B, C, D, again A. So this schematic diagram is for the mercury, and a certain amount of heat is utilized in case of the steam turbine before it is entering to the turbine, and then it will be condensed inside the condenser. Then it is the feed form. Again, it will be circulated inside this economizer. Okay, so let me explain you one by one. So in case of the mercury cycle, first the mkg of steam will be entered to the mercury turbine. Then it will be expanded in the process A to B, and then B to C will be the heat rejection process. So whatever the heat is rejected, that will be go to this is the process 6 to 1, right? Uh, so this is the 6 to 1. So 6 to 1 is nothing but it is the superheater. The name is given superheater. So whatever the heat will be rejected, that is the 5 to 6 process. That will be B to C process, that will be utilized in case of the 5 to 6 process, right? So here it is utilized in case of the 5 to 6 process. So that saturated liquid will be converted into the saturated vapor by absorbing the heat from the mercury condenser, and then this saturated vapor will be converted into the superheated steam in case of the superheater. So the superheater process is 6 to 1. So this is the 6 process 6, and this one is your 1.1. So process 6 to 1 is your superheater. So where the saturated vapor will be converted into the superheated steam, right? So then there that 1 kg of steam will be expanded in the steam turbine. So here we will get the work output. So which is that shaft work is converted into the electrical work. So here it is generator is connected. Then there will be the after the expansion process. So this is the condition of your uh, condensate. So it is having the certain percentage of the uh, liquid vapor mixture. So here we will have the dryness fraction values. So then there will be the after that expansion process, there will be the condensing process. So the condensing process will be done in case of the steam condenser. That process is your 2 to 3. So this is the 2 to 3. So there will be the heat rejection in this case. So here it is a heat exchange process, and here it is the heat rejection process. So 2 to 3 is the steam condenser process where it will reject the heat. Then that saturated liquid will be pumped with the help of the water feed pump to the boiler pressure. So that pumping process we are taking as 3 to 4. Okay. So after the pumping process, there is the process that is the 4 to 5. Here we have given the process name 4 to 5. So this process is to increase the temperature of the compressed liquid. Okay, so this is the condition of the compressed liquid. So that temperature will be increased up to the saturation temperature. So if you are observing, so this line is the patching process will occur at the saturation temperature. So compressed liquid temperature will increase to the saturated liquid with the help of your economizer. So this is the economizer. So here heat will be in exchange with the adjust of this one is so the process 4 to 5, right? So this one is the 4. It is the 5. Okay. So again, this process will continue.
मैम
Oh, tell me.
यहाँ पे मैम बी टू सी में जो हीट रिजेक्ट हो रहा है मरकरी का वो 5 to 6 में वो इक्वल हो
यूटिलाइज हो
जाएगा
रही है,
5 to 6.
हाँ इक्वल हो रही है. जो
ओके ओके मैम.
रिजेक्शन हो रही है वो डायरेक्टली ये 5 to 6 में यूटिलाइज हो रही है, हीट एक्सचेंज प्रोसेस हो रही है ना. वन टाइप ऑफ वी कैन से इट इज द हीट एक्सचेंज प्रोसेस. ओके
ओके मैम.
ओके. सो पहले रैंडम साइकिल में क्या था, 4 to 1 तक हम दिखाते थे, पर यहाँ पे हमने 5 to 6 पॉइंट पे दिख रहे हैं. ओके, क्योंकि ये आपका जो हीट रिजेक्शन हो रही है कंडेंसर में मर्क्यूरी का हाई टेम्परेचर रेंज में है, राइट. तो ये यूटिलाइज हो रही है यहाँ पे। ओके, तो ऐसे करने में क्या होगा, जो आपका प्रेशर, जो टेम्परेचर है, मीन टेम्परेचर हीट एडिशन, अब वो बढ़ जाएगी। ओके, जैसे कि वो आपका एफिशिएंसी को इंक्रीज कर पाए। ओके, so this is the schematic diagram for the binary vapor cycle. So first cycle is known as your topping cycle. Below it is the bottom cycle or bottoming cycle. Okay, so this is the binary vapor cycle. So you can use instead of the mercury cycle, you can use the sodium oxide also. So you can use the another potassium as a working fluid also, you can use it. So nowadays people are not utilizing 3 decades before, 2 to 3 decades before it was utilized. Nowadays people are not utilizing, but in near future we can use this type of cycle, because as you all know, the coal is nowadays it is presently not that much available to generate the electricity, but this mercury, this can be used as one of the option. Okay, so this is your binary paper cycle. So now we will do some calculation related program. Okay. So now we'll discuss the what is the amount of heat addition in this case, and what is the heat rejection, turbine work, and pump work, and what will be the plant efficiency. So we will discuss one by one. So first, let me discuss the what is the energy balance equation for this. So energy balance equation will be utilized at this point, right? So whatever energy is rejected by the mercury in case of the mercury condenser, that is utilized in case of the steam boiler, right? So that process is your 5 to 6. So from there we can find out what is the amount of mass of mercury we can utilize to generate the 1 kg of steam. So let us consider M is the mkg of mercury is utilized per kg of the steam to generate the steam. So uh, right. So then energy balance equation will be so here it is the M. So in enthalpy change we will discuss, that is the HV minus HC. So this we can find out at the condenser pressure, which is equal to, it is let us consider mkg of mercury is utilized to generate 1 kg of steam. So here it will be 1 into the enthalpy change is your H, it will be the H6 minus H5, right? So then we can find out what will be the mass. So mass will be H6 minus H5 upon Hp minus Hc. Okay, so this is the kg of mercury required to generate kg of steam or water. Okay, whatever may be. Okay, okay, or we can say it or kg of water. So M is the, it is the, let us consider that 1 kg of or to heat 1 kg of water can use 7 to 8 kg of mercury. Okay, so 7 to 8 kg of mercury can be utilized to heat 1 kg of water. That can be find out from this relation. Okay, so now we will write down what will be the heat addition for this process. So what will be the heat addition for this process? Can anyone tell me?
H6 minus H5, H1 minus H6.
So heat addition will be the mkg of mercury is utilized, right? So here there will be the
HA
heat
minus
addition.
HD,
Ha minus
HA minus
hd
HD,
plus, here again we are adding the heat. So that is your, how much it is? H6 minus H5. Hmm. No. So ये तो heat exchange process हो रही है. So
yes ma'am. H1 minus H4 minus H5 minus H6.
so this will be the यहाँ पे सुपर हीटर यूज हो रही है, यहाँ पे इकोनोमाइजर यूज हो रही है ना. So this will be the H5 minus H4 plus H1 minus H6. Okay, so this will be the heat addition. Then heat rejection is your, simply it is the H2 minus H3. So similarly turbine work. So turbine work will be the M HA minus HV plus 1 into H1 minus H2, right? So similarly compressor work. So it will be the M HD minus HC, and here it is 1 into H4 minus H3. Okay, so this is the compressor work. Now we can find out what will be the efficiency of the cycle. Okay, efficiency of the binary cycle. 1 minus Q2 minus Q1, which is Q1 minus Q2 upon your Q1. So what is the steam rate formula?
3600.
Hmm?
3600 by W net.
W net. So what is the W net here?
W W turbine work minus
Turbine
pump.
work minus pump
Blue.
work.
Okay. So now we'll discuss the okay. So steam rate will be 3600 upon your W net. W net is your turbine difference of your turbine work and your pump work minus WP, right? So now we will discuss the this is the diagram related to the cogeneration. So cogeneration means here what we are doing, we are using the some waste heat in the plant so that that heat can be utilized for, as a process heat. That heat can be utilized as the process heat. I think already I have told you what is the process heat. Process heat means that heat can be utilized in the plant itself. So some heat can be utilized in the process industries like your paper industries and your refineries, in case of your oil industries, in case of your textile. So there we can utilize some waste heat without given to the atmosphere. So this is the diagram for that cogeneration plant. So if you will observe in this case, suppose in industry there it is generating the power, as well as the exhaust heat can be utilized uh, to improve the plant efficiency, as well as that heat can be utilized in the industry itself for certain operations. Okay. So, in case of the process industry, that process heat pressure is generally that heat is your 250 degrees Celsius to 600 degrees Celsius as per the requirement. Okay, so generally this range they are utilizing, and that pressure is your 5 to 7 bar. Okay, so if you are observing this diagram here, it is the schematic diagram for the cogeneration plant. This is your boiler, and it is connected to the turbine. In between, certain amount of heat we are extracting from the turbine, and that heat, as per our requirement, we can extract at the particular temperature and particular pressure, and that is utilized in the process heating arrangement. Like your as I have already told you, dyeing or generate pressing. So for that purpose, that steam can be utilized. So let us consider the M1 kg of steam is drawn for the process heating. So that at the outlet, we can say that amount of heat is again, or condensate is again removing from that process heating process. Uh, then and that is combined with this condensate, and that will again continue to the boiler as a feed water, and that feed water can be pumped to the boiler at the boiler pressure. Okay. So here, if we are drawing the M1 kg of the steam for the process heating, then remaining amount of steam will be expanded in the turbine. At the outlet of the turbine, we are getting 1 minus M1 kg of the steam. So this steam is utilized in case of the condenser, and at the outlet, as it is the theoretical process, we are considering the theoretical process. So in that case, we are not considering any losses. So at the outlet of the condenser, again we are getting the 1 minus M1 amount of condensate, which will be pumped to the here it is the one arrangement where both condensate or steam will be mixed, and which will be converted as the 1 kg of the condensate, and that will be pumped to the boiler. So this is your cogeneration. So in case of the cogeneration plant, we can use the uh, different cycle in combination. So there we are having the steam cycle, gas power cycle. Okay, so under this gas power cycle, I have told you that there are different type of gas power cycle: Carnot cycle, another one is the Stirling cycle, Ericsson cycle, and Brayton cycle, and then your Otto cycle, Teachel, Dual. Okay, so these can be utilized in combination with these two cycles. So that will be considered as the cogeneration cycle. So in case of the cogeneration cycle, we are considering the utilization fraction. Okay, so utilization fraction means it is we are representing in terms of your EU. So in this case, the equation will be your W net plus Q out upon your Q in. Okay, so Q out is nothing but it is a rejected heat which will be utilized in case of this equation. So W net means it is the net work output in the cycle, cogeneration cycle, and it is the net heat added in the cogeneration cycle. Okay, so we can find out the utilization fraction from this equation. That's my point. So this is all about your cogeneration system, where we can utilize the exhaust heat in case of your industry, and also you can draw the certain amount of heat for your as your process heat for the certain application. So in case of the industry, in thermal industry generally, that industry are meant for the power generation, and another is the for process heat generation for utilization of process heat. Okay, so this is your thermal industry. Okay, so this process heat utilization, maybe it is this is one method where you can draw the certain amount of heat at the particular temperature and pressure as per your application. And another one is the exhaust heat recovery system. So there you can use the two cycle in combination. So the heat without rejecting to the atmosphere, that can be utilized in the another cycle. So it is all about your cogeneration. Then this is the so here we are going to find out the efficiency, overall efficiency of the coupled cycle. So if two cycles are utilized to generate the uh, power or work output, so in that case, what will be the thermodynamic analysis? Thermodynamic analysis means we are finding the overall efficiency and comparison of this efficiency of the individual plant. So if you are observing in this case, here we are considering the topping cycle and bottoming cycle. So if you are taking the example of your binary paper cycle, so here it is the topping cycle, means here it is the boiler and it is the turbine. So suppose m1 kg of the working fluid is entering to the turbine, then there will be the expansion. Then this is the heat exchange process. Here it is the heat, whatever the heat is rejected, that is utilized in the another cycle. So here the heat addition is the Q1 in case of the topping cycle, and heat rejection will be the Q2. In case of the bottom cycle, the heat addition is the Q2 and heat rejection is your Q3. So here it is the two thermodynamic cycle are utilized. So first case, the heat addition is the Q1 and heat rejection is your Q2, right? So in this case, the efficiency for the topping cycle will be, let us take it is the topping cycle. So efficiency will be the eta top, so which is equal to 1 minus Q2 upon your Q1, right? So similarly, in this case, in case of the bottom cycle, we are having the eta B, which is equal to your 1 minus Q3 upon your Q2, right? So this one we can also write as the letters eta top is, it is eta 1, it is eta 2. So it is that Q2 can be represented as, is it right? 1 minus Q2 minus Q1. Okay. 1 minus Q2 upon Q1. Q1 minus Q2 upon your Q1. Q2 minus Q3 Q2, which is equal to Q2 eta 2 Q2 minus Q3. So the eta 1 will be how much? It is Q1 minus Q2 upon Q1. So in this case, Q2 will be Q1 1 minus eta 1 1. Q3 is your Q2 1 minus eta 2 equation 2. Then your overall efficiency will be eta, which is equal to 1 minus Q3 minus Q1. Okay. So Q3 minus Q1, this can be written as Q3 upon Q2 into Q2 upon Q1, right? No. So this will be in place of the Q3 upon Q2. कितना लिखेंगे? So this will be the Q3 1, which is equal to Q3 upon Q2 multiplied with Q2 upon Q1, right? Q3 upon Q2, which will be 1 minus eta 2. In Q2, Q1, it will be the 1 minus eta 1. So let us rearrange this one. So it will be the 1 minus eta 1. Here it is the 1 minus eta 2. Okay. So then equation 3 will be overall efficiency of the coupled cycle will be how much it is 1 minus eta 1 eta I 1 minus eta 2. Okay. So if there are the n number of coupled cycle, then we can write as overall efficiency will be 1 minus I 1 minus eta 2 1 minus eta S. Okay, so this is the overall efficiency for the coupled cycle. So here the two cycle are used. Here it is the n number of cycle. Okay, so this is all about your thermodynamic analysis of your coupled cycle. So if the efficiency of one cycle is given, then you can find out another cycle efficiency, then you can find out what will be the overall efficiency. Okay, so this is all about your cycle discussion or working cycle discussion. So from the next class onward, I'll take your boiler, different types of boilers and what are the accessories and mountings are available. That one I will discuss to you. Okay. Anyone is having any doubt? Cogeneration is over, binary cycle is over. Then we are having the thermodynamic analysis of your coupled cycle. Okay, let me take your attendance. Roll number 1, 2, 3,
Present, ma'am.
4, 5,
Present, ma'am.
6,
Present, ma'am.
7,
Present, ma'am.
8,
Present, ma'am.
9, 10, 11, 12,
Ma'am.
13,
Present, ma'am.
14,
Present, ma'am.
15,
Present, ma'am.
16,
Present, ma'am.
17,
Present, ma'am.
18,
Present, ma'am.
19,
Present, ma'am.
20,
Present, ma'am.
21,
Present, ma'am.
22, 23,
Present, ma'am.
24,
Present, ma'am.
25,
Present, ma'am.
26,
Present, ma'am.
27, 28,
Present, ma'am.
29, 30, 31,
Present, ma'am.
32,
Present, ma'am.
33,
Present, ma'am.
34,
Present, ma'am.
35,
Present, ma'am.
36,
Present, ma'am.
37, 38,
Present, ma'am.
39,
Present, ma'am.
40, 41, 42, 43,
Present, ma'am.
44, 45, 46, 47, 48,
Present.
49, 49, 50, 51,
Present, ma'am.
52, 53,
Present, ma'am.
54,
Present, ma'am.
55,
Present, ma'am.
56,
Present, ma'am.
57,
Present, ma'am.
58, 59,
Present, ma'am.
60,
Present, ma'am.
61, 62,
Present, ma'am.
63,
Present, ma'am.
64, 65, 66, 67,
Present, ma'am.
68,
66 present, ma'am.
67, 68, 69, 70,
70 present, ma'am.
71, 72,
Present, ma'am.
73,
Yes, ma'am.
74, 75,
Present, ma'am.
76, 77,
Present, ma'am.
78, 78, 79,
Present, ma'am.
80,
Present, ma'am.
81, 82,
Present, ma'am.
83, 84, 85, 86,
Present, ma'am.
87,
Present, ma'am.
88,
Present, ma'am.
89,
85 present, ma'am.
90,
Yes, ma'am.
91,
Present, ma'am.
92,
Present, ma'am.
93,
Present, ma'am.
94,
Yes, ma'am.
95,
Present, ma'am.
96, 97, 98, 99,
Present, ma'am.
90, 100,
Present, ma'am.
101, 102, 103,
Present, ma'am.
104,
Yes, ma'am.
105,
Present, ma'am.
106,
Present, ma'am.
107, 107, 108,
Present,
109,
ma'am.
109,
Present, ma'am.
110, 111,
Yes, ma'am.
12,
112 present, ma'am.
13, 113, 114,
114 present, ma'am.
115,
Present, ma'am.
116, 117,
Present,
Present,
ma'am.
ma'am.
117,
Present, ma'am.
Vandana, Varsha
116,
Ramani.
ma'am.
Okay. 118,
Present, ma'am.
119,
Present, ma'am.
120,
Present, ma'am.
121,
Present, ma'am.
122, 122, okay.
Ma'am,
Ma'am,
please.
ma'am, roll 70. Ma'am, roll 76. Actually, I was there. Ma'am, mic was not switching on. That's why I wasn't able to
Okay.
speak up.
Anyone?
Ma'am,
Ma'am, roll.
roll 85.
Okay.
Ma'am, roll 2.
Ma'am, 98,
roll
ma'am.
10. Ma'am,
Roll
45.
1, 2 are absent.
98,
45.
ma'am.
Roll 2 is present.
Roll 1, ma'am.
No, absent.
Roll 10, ma'am.
Okay.
Ma'am, 45.
9.
Mm.
22.
1,
Okay.
ma'am.
Okay.
Ma'am, 98.
Ma'am, 45.
हो गया चलो